But we're going to look at page 60 and talk about doing some problems with Venn diagrams. Okay. So we have two examples. One of them, everything is filled in for you. So let's do this one first and see how we manage. So these are the M&Ms, these are the Twix, 11, 6, 9. All right, so what this means, this 30 out here, it says there are 30 students in the class. So that means this box contains 30 students, okay? There are 30 students. So pretend it's this room, all right? And I say, how many of you like M&Ms? And some of you raise your hand, and that's why I write that down. How many of you like Twix? Raise your hands, and I write that down. There were some people who raised their hands twice, weren't there? Those people are represented right here. All right, so let's see if we can answer the question. How many kids like M&Ms? 17. I hear two answers. Which one's right? 17. 17. Kids, if you are in the M&M mall, you like M&Ms. Now, you may or may not also like Twix, but all these people like M&Ms. Would you agree? Okay. How many like only M&Ms? That's the 11, because these guys are in the M circle, but not in the T circle, so they like only M&Ms. How many like both? 6. How many like M&Ms or Twix?
26.
There are 26 people that raise their hands, right? 26 people raise their hands. How many like only M&Ms or only Twix? 20. You guys are good at this. Very good. How many like neither candy? 4. Because remember, the box holds 30 people. If only 26 of them raise their hands, there's 4 weirdos out there who don't like candy, right? Perfect. Easy. All right, number 4. So there are 28 students in the class, and everybody likes jazz or country or both. Draw a Venn diagram showing the following, and then answer the question, how many students like only jazz? Oh, this is a little tricky. So the given information is there are 18 who like jazz, and there are 14 who like country. Now I want you to think for just a minute about having 28 students in the room. How many of you like jazz? And up go 18 hands. Okay? How many of you like country? Up go 14 hands. Now the problem tells us that everybody likes one or the other. So everybody raised his hand at least once. Okay? So 18 hands went up for jazz and 14 hands went up for country. I have a problem. How many hands is that? That's 32 hands. How many kids are in the room? 28. What does that mean? 4 extra hands went up, and that means they went up twice. Stop and think about that. Make sure that makes sense. You're going to have to be able to do this. We are guaranteed that everybody in the room raises his hand. Okay, so nobody's just sitting there. Everybody's participating. There's 28 of you. 18 hands went up for the one kind, 14 went up for the other kind. That's too many hands because there's only 28 of you. How many extras? 4. So those 4 people raised their hands twice, so they're represented there. Okay? Now, tell me how many go here. 14. Because we know the problem told us that 18 kids like jazz. this is the jazz circle. If 4 of them have already been counted, the doublers, then there must be 14 over here. And what about the country kids? How many over here? 10? Now notice, what do we add up to here? 28, because everybody in the room participated, right? We didn't have anybody hanging out. Everybody's in there. Now we can answer whatever question. This one is, how many students like only jazz?
14.
14, right here. This is the kids that like only jazz. Does that make sense to you? Okay, now we need to do 2 things, but not new things. We're done, that's it. Oh my gosh, you just learned your last new thing.
Oh my gosh. That means pre-cal.
Okay, no, pre-cal is not over.
We're having a party.
Now,
We have a party?
I want to do another expansion. Okay, and then I've got some old practice I want to do, and then if we have time, we'll look at our practice quiz for our big quiz next time we're together. Okay, so here we go. Let's do this expansion. All right, so we're going to do this expansion. This is not in your packet, so you can either do it somewhere in the packet or get it on another piece of paper or something. This is just an extra practice problem because we need to be able to do it. So you can do it anywhere in your packet because we're not using it anymore. All right, so who remembers, we just did one of these. Who remembers how we start?
1, 3x, y.
We've got to go to the 4th row of our triangle. Now you may already have that written down from the other example we did, but if you don't have it written down, then you're going to have to build it real quick. And we're only going to build it down to the 4th row because that's the row I need, right? So I'm going to write down the numbers 1, 4, 6, 4, 1. Those are the numbers in that row of the triangle. Now what happens next? Next to everything, all these numbers, I'm going to put a 3x and a y. Okay. Now, I recommend you put these big plus signs in there. That's up to you completely. They're always plus. They're just separating each term. And then there's one more thing I need to do. My exponents. So this is to the 4th now, so we'll put a 4, 3, 2, 1, 0, and then 4, 3, 2, 1, 0. Is that okay? Now we're all done except for the simplifying. So let's look at each term individually. Remember, to the 0 power is 1. So, oh no, that's not 12. What is that? That's 81. Because this is 3 to the 4th, which means 3 times 3 times 3 times 3. Now you're sitting there with a calculator. The arithmetic is manageable. 81 x to the 4th. Plus, all right, now we're going to do this one. Now be careful. What kids will do is multiply 4 times 3. That's not right, because that 3 is actually getting cubed. So it's 27 times 4. 108. I hear a lot of chatting over there. I hope you're paying attention to me because this is an exam question and this is a quiz question. Make sure that you are raising whatever's in the parentheses to the power as you go. All right, what happens here?
4 x squared y squared.
It's 54
x squared y.
X squared y squared. So again, I'm encouraging you not to trust your own arithmetic. You have a calculator. If you can't remember that 9 times 6 is 54, then don't guess. Type it in. 54. All right, what about this one? That one is 12. Why is that one 12? Because that's just a 3. And the last one?
Y to the 4.
Is y to the 4. Anything to the 0 power is 1. Anything to the 0 power is 1. So this is just y to the 4th. And that is your final answer. Now, what if the question had said, okay, you got the same problem. What if it had said, find the x squared y squared term? Well, do we have an x squared y term up here? Yes. So instead of looking at all the terms, we would single out the one they asked for, which is that one right there. So if you looked at your exam review sheet, that's the way the question's worded on the exam. It doesn't ask you for the whole expansion, it asks you for one particular term. You can still find the whole expansion and then just pick out the one that you want. Okay, all right, so if we have time, we can do some more of those practice. I have one more thing I want to do though. I want you to practice these. How many percent?
I'm at a 91 for the semester. What? I just tried to get
Okay, did everybody get one? All right, let's start on the side. We're going to start on the side that says, question number 1 says, how many ways can I arrange 7 books? So we're doing a side that says, how many ways can I arrange 7 books in a row? So 7 books in a row would be 7 factorial. And in the answer blank, we put the value of 7 factorial, which is 5,040. I'll say it one more time. You get 3/4 credit for writing 7 factorial, for knowing that's the answer. The other 1/4 comes from typing it in on your calculator and getting 5,040. So if you don't have a calculator or don't know how to use your calculator, you're going to miss a 1/4 of every question. All right, number 2. How many ways can I choose a committee of 6 from a group of 10?
10 times 9 times.
Now, we talked about this the other day. If you have 10 people and you are picking 6, you can do it either this way or you can do it this way. This is how you pick 6 out of 10. Now, does anyone remember the difference between these two?
He has an order.
Exactly. So you got to ask yourself the question, does order matter? Now pay attention to what you're doing. You're picking a committee. Does the order I pick you matter if I'm just picking you to be on a committee? No. So this is going to be a C problem. Number 2 is a C problem. It would be a P problem if I were giving you specific titles like president, vice president, whatever, but I'm not. I'm just saying you're in my group. And the answer is 210. So you need to make sure you're getting 210 as your answer. So we get 3/4 credit for recognizing the setup, and then 210 gets us full credit. All right. Number 3, how many outfits are possible if I have 10 shirts and 11 jumpers? 10 shirts and 11 jumpers. We talked about it. I'll come to class. We'll figure it out. 10 shirts and 11 jumpers. The answer is 110. 110.
We take a point off, we don't write 10 times.
If you don't show any work and you have the wrong answer, you get no credit. So I would show some work, just in case. How many ways can I award a pencil, an eraser, and a calculator to a group of 8? All right, now wait a minute. Stop and think. How many kids are there? 8, and I'm picking 3. So this is another one where I have to decide, does the order matter? If I am giving away a pencil, an eraser, and a calculator, does the order matter?
No.
Heck yeah, it matters, right? If I give Rylan the pencil and Caroline the eraser and Harry the calculator, he's happy. And that's different than giving Rylan the calculator and Caroline the pencil and Harry the eraser. When you're giving away specific things, different things, order matters. It's like president, vice president, treasurer. Order matters. So this is definitely a P problem. And the answer is going to be 336. Now, when they are P's, you can also set them up like this. You can't do that with C's, but with P's, you can say, okay, I have 8 choices to give first prize to, and then 7, and then 6, and that'll give you the same answer. P's go that way. You can do P problems that way. You cannot do C problems that way. All right, I love you. How many ways can I arrange
8.
the letters? 1, 2, 3, 4, 5, 6, 7, 8. So I start with 8 factorial. Now, why did I put that division sign in there, Judah? It has matching letters. So we got, what, 2 O's? So 2 factorial, that's the O's. Is that all?
Yeah.
So the answer is 8 factorial divided by 2 factorial. So 20,160 is your answer. 20,160. Oh, and then we have a bonus question on this quiz. How many committees of 3 boys and 2 girls can be chosen from a class with 6 boys and 10 girls? Anybody want to hazard a guess at this bonus question?
Spots for the boys, 2 spots for girls.
What'd you say?
3 spots for boys, 2 spots for girls, 7, 10, 9, 8, 6, 5.
Now, I want to talk about that for a second because I get that logic completely, but it's wrong. Because as soon as you do this, Jack, as soon as you write that down, you're doing it in order. And this problem has no order. The order that I pick the kids is irrelevant. So what I want you to think about is, let's look at just the boys. Just the boys. How many boys are there? 6.
Infinite.
And how many am I picking? 3. And the order doesn't matter. So here are my boys. That's the number of ways that I can pick boys. Now, what about the girls? How many ways can I pick the girls? 10 C2. Now, both of those are numbers. I think this one might be 45.
Yeah.
And this one's 20, I think. Okay? So, if I just look at my boys, I can pick 3 boys 20 ways. If I just do the girls, I can pick my 2 girls 45 ways. Now, I need to pick both, right? I need to pick boys and girls, just like I pick a jumper and a shirt. So my answer is going to be 20 times 45, or 900. So there are, if I multiplied right, so there are 900 ways to do that. That's a bonus question, but it's kind of cool, isn't it? All right, let's turn it over. That'd be awesome. We should be. We're probably. All right, number 1 on the other side. How many ways can we arrange I miss you?
8 factorial.
8 factorial divided by
4 factorial.
So once again, we have 8 letters. So we start with 8 factorial. Now 2 of them are S's, so that's a 2 factorial. 2 of them are I's, so that's another 2 factorial. Don't put those together. It's not 4 factorial. It's 2 factorial, 2 factorial. So when I divide that,
40,300.
I got 10,080.
I got 40,000.
I got 40,000. Yeah, so I got 40,000.
I got 10,080. I got 40,000.
Yeah, 40,000.
Okay, wait a minute. What did we get? What did you get for, just do 8 factorial. What did we get for 8 factorial? 40,320. Now you have to divide that. What's 2 factorial? 2. This is another 2. So essentially I'm dividing by 4, not 4 factorial, but by 4. And that's 10,080. So I'm not sure what you're doing.
I put that in.
I plugged it all in at, if you plug it all in at once, it multiplies the 2, so yeah, it doesn't.
Because you're not putting this in parentheses. Okay, we talked about that the other day. If you are dividing by more than one thing, you must put it in parentheses. Otherwise, what's happening is it's dividing by 2 factorial and then turning around and multiplying by 2 factorial, which is not what you want. You want it to divide by both things, so you have to tell the calculator to divide by both things. Boys and girls, there's one thing you need to get clear on. When your calculator gives you the wrong answer, it's not the calculator, okay? It's not. It's operator error every single time.
Here's your right answer. It's not your answer.
The wrong answer is the problem. All right, here we go. Number 2. How many different cakes are possible if we have 6 kinds of cake and 10 kinds of icing? 60. You have 60 cakes possible. How many teams of 4 can be selected from a class of 10? All right, now stop and think. You have 10 kids. You're picking 4. Is this a P or is this a C? It's a C. Because if you're picking a team, you just want to be on the team. You don't care when you get picked.
Some people
I got 210 again? 210 as the answer? All right. How many ways can I arrange 6 people in a row? 6 factorial. So this problem is 6 factorial, which is 720. No, yeah, 720. How many ways can I choose a president and a treasurer
22P.
from my class of 22? So 22 kids, I'm gonna pick 2. Does the order I pick them matter? Yes, because they're getting specific jobs. So this would be the answer, which 462, I'm taking his word for it. You could also do that problem as 22 times 21, which should give you the same answer. Doesn't matter which way you do it. My warning to you is, though, you cannot do C problems with blanks. So be careful. You're not going to be able to blank every problem. Not going to be able to do this with every problem. All right, and then this one has a bonus too. How many 5-card hands contain 3 clubs and 2 red? Now, this is sort of like the one we just did that was boys and girls, and we did them separately. So let's do these separately. How many clubs are in a deck of cards? 13. And from that 13, we are going to pick 3. And the order we pick them doesn't matter. We just need to select 3 clubs from the pile of clubs. Okay? Now, how many red cards are in the deck? 26. And I am going to pick 2 of those. And again, the order doesn't matter. Doesn't matter what order I get. I just want to get 2 red cards. So 13C3 is an answer. 286. And 26C2 is 325. Hopefully I did that right. Yeah. Now, I can pick my clubs this many ways, and I can pick my reds this many ways. So I'm going to multiply these together because I have to do both. So 286 times 325, 92,950 hands that contain 3 clubs and 2 reds. Okay? All right. Now, okay. I'm going to go ahead and hand out our practice quiz. So the next time we're together,
There was one episode where they were doing that at the bar, and then they threw it up, and then later, like at the end of the episode, they're just sitting there, and the episode just falls down, and it bounces, and goes up, and one of the guys knows, and they're just like sitting like
okay.
I remember.
So,
this is where we didn't get practice.
all right, let's get through the first problem on our practice quiz. Everybody Everybody's paying attention?
Basically how we was, and I wrote 7 books.
Here we go. This is our chart. Your quiz is going to have a chart on it like this. We've got bowls of colored beads and everything's measured. Percentages are there. Here we go. One bead is chosen from each bowl. What is the probability that both are blue? Well, what's the probabilities Olivia's will be blue? 0.3. And we need Thomas's to be blue. 0.5. So the answer is 0.15. And again, you let your calculator do the work if you need to. What is the probability neither are green? All right, so what's the probability that Olivia's won't be green? 0.6, that's right. What's the probability that Thomas's won't be green? 0.8. So your answer is 0.48.
Do you want us to write it in decimal form?
You can write it as decimals or percentages. It's completely up to you. That would be 48%. All right, and then finally C. What is the probability that one is green and one is yellow? Now be careful. This is the trick question. Because we could get green and yellow, or we could get yellow and green, and that's different. Those are different cases because they're coming out of different piles. So, green from Olivia would be 0.4, and yellow from Thomas would be 0.3. Or we could get yellow from Olivia and green from Thomas. So adding them together, because it's this or this, it's the total probability, the answer would be 0.18 or 18%. Okay, you're out of here. Yep, I will see you tomorrow, I think, I hope. What?
Miss Monroe drew on a smart part. She did that last year with the Sharpie. She always does that. And they're like, you did it with the Sharpie, and it's just, it'll come off. That's also mine. Oh shit, my ramen, bro. We're the only two. Spicy ramen. French spicy.
All right, have a great day.
Is this the lunch period?
Yes, this is the lunch period now. Here's the lunch period.
I think he's.
Oh, Miss Ford, I figured out how to type it in. I remember.
Well, good. You can still come during flex.
Yeah, I probably will.